All right, this lesson is going to be on multiplying polynomials. Um, it's gonna be very similar to the distributive property lesson that we did very early in the school year. Um, but what I'm going to be doing now is teaching you something called Punnett squares. And forgive me if I'm spelling it wrong, but what Punnett squares are a way of multiplying hard distributive properties. Okay, let me give you an example of a Punnett square. If I was multiplying 12 times, let's say, 13, what I could do is I could think in my mind as 12 is really 10 plus 2, and 13 is 10 plus 3, right? And what I could do is I could actually make a multiplication grid. What I would do is this. I would do 10 sorry, my pen died for a minute. 10 plus 3 would go here, and or 10 plus 2. It doesn't really make a difference. So 10 plus 2 and 10 plus 3. And then what all I would do is I would multiply each grid. So 10 times 10 is 100. 10 times 3 is 30. 10 times 2 is 20. And 2 times 3 is 6. So I'd have 156. The reason, what I just did there is the same exact reason that when you multiply 12 times 13 like this, when you start going through the multiplication algorithm, you're actually doing this. And I'm not going to spend the time doing that right now just for the sake of time, but you're actually doing something very, very similar between these two. All right? What I want you to get here is this. If you're multiplying a parenthesis that has addition in it times a parenthesis with adding or subtracting in it, okay? What you're going to have to do is you're going to have to understand that you're going to multiply the 10 times this and the 10 times that, the 2 times this and the 2 times that. Now, the best way I've come up with doing that is doing something like this, all right? Now, with numbers, it's no big deal, but when you get into variables, I want you to actually start using this. Let me tell you right now, guys, I've seen a lot of teachers teach this differently. And I've learned over the last couple of years that I really do think this is the best way to teach multiplying polynomials, is using this Punnett square. So this is what we're going to do. What you need to do is figure out how big your square is going to be. All right? Well, it's going to be, that's one term and that's two terms, so it's going to be a 1 by 2. So what you're going to do is you're going to make a 1 by 2 square. So 1 by 1, 2. The x is going to go here. The 7x squared plus 4 is going to go here. Pretty easy. And then all you do is you're going to multiply it. 7 times x squared times x means 7 times x times x times x, which is 7x to the third. And then x times 4 is 4x. And then this will be my answer. So my answer is 7x to the third plus 4x. Now, a few of you right now are probably watching this video saying, well, couldn't I just distribute the x? Absolutely. I'm showing you another way of doing the exact same thing now, okay? And when the variables get in, when these powers of x's get involved, I really do think this is a better way of doing it. You're not going to make very many mistakes, okay? So let's see another example. 2y times 3y squared minus y. Well, there's one thing here, and there's two chunks there. So I'm going to make another 1 by 2. So this is 2y by 3y squared minus y, right? And it doesn't hurt to put the 1 there if you want. So what I want to do is I want to do 3y squared times 2y. Well, 3 times 2 is 6. Y squared times y means y times y times y, which is y to the third. And 2y times negative 1y is negative 2y squared. So what do I have? I have 6y to the third minus 2y squared. Example 3. This is the first problem where distributive property, the way I taught you earlier in the year, is actually not going to work. How do I multiply a polynomial by a polynomial? Okay. What I need to do is understand that I'm going to make a Punnett square, but in this case, There's two chunks here and two chunks there. So what I'm going to do is make a 2 by 2 square. So in this case, it's actually going to be a square. So this is going to be a plus 3. You can put the a plus 3 here. It doesn't make a difference. This is going to be 2a plus 1. And then 2a times a, remember that's 1a there. You can put the 1. 2 times 1 is 2. A times a is a squared. Then 2a times 3 is 6a. 1a times 1 is 1a. And then 1 times 3 is 3. Then you can write it out. This is 2a squared plus 6a plus 1a plus 3. And hopefully by now you're realizing, well, can't I add those together? Yes. You get 2a squared plus 7a plus 3. Okay. When do I use this? This is you start learning this new method and you're not sure when to use it. This is when you use it. When you're multiplying a parenthesis times a parenthesis, I would recommend you use Punnett squares. A parenthesis times a parenthesis, I would recommend Punnett squares. All right? A little side note real quick. When you do these kind of problems, about 95% of the time, those two chunks will end up being added together. See how we had the 6a and the 1a? These two can be added together. So when you do this problem, you might want to just do that in your head right then and there. Instead of writing it, just go ahead and add these. Look at that diagonal, and they're probably going to be able to be added together. Okay? All right, example 4. 2 chunks by 2 chunks. That means I'm going to make a 2 by 2. This is 4n minus 1. This is n plus 5. Put the 1 there if you want. 1n times 4n is 4n squared. 1n times negative 1 is negative 1n. 5 times 4n is 20n. 5 times negative 1 is negative 5. And just like I said before, see this diagonal, these can be added, right? So what do I end up with? I end up with 4n squared, because I write n squareds first. 20n plus a negative 1 is 19n minus 5. And there's my answer. Got it? All right, next problem. This time I'm multiplying two parentheses, and I have 3 things here. So this time I'm going to do a 2 by 3 because there's 2 things in the second one and there's 3 in the first one. So I'm going to do 3 this way and 2 that way because I have a longer paper this way. All right, so I have 1b squared, 6b, negative 7. I have 3b minus 4. 3b times 1b squared, well, 3 times 1 is 3. B squared times b is b times b times b, which is b to the third. 3b times 2b is 6b squared. 3b times a negative 7 is negative 21b. 1b squared times negative 4 is negative 4b squared. Negative 4 times 2b is negative 8b. Negative 4 times negative 7 is 28. And just like before, notice these diagonals, right? This diagonal can be added together. And this diagonal can be added together. Okay? So what do I have as my answer? What do I have? I have 3b to the third. Oh my gosh, that is getting annoying. Every time it changes back to a big fat chubby marker. All right, so I get 3b to the third. Now 6b squared plus negative 4b squared is 2b squared. And negative 8b plus negative 21b is negative 29b. And I have a 28 left, so plus 28. And that's it. if you try to do foiling, if you try to do, if you try to solve this problem some other methods, and some teachers would teach to multiply the 3b times this, the 3b times that, the 3b times that, the negative 4 times this, the negative 4 times that, the negative 4 times that. If you do it that way, there's a really good chance you're going to make a dumb mistake and miss it. Okay? I really do think doing Punnett squares for multiplication keeps you from making dumb mistakes. All right? Next example. Example 6. In this case, I want you to understand what's happening. You're doing 2x times this, and then you're multiplying this, x plus 1 times x plus 2. So the way I like to look at this problem is I like to do this whole problem by itself, and then I like to do this whole problem by itself, and then I bring the two answers together. Okay? Okay, so I'm going to do the two Punnett squares now, and the first one is going to be a 2 by 1. So this is going to be 2x plus 3. And this is going to be 2x. The other one is going to be a 2 by 2. So this is going to be x plus 1 by x plus 2. Okay? Then just go ahead and multiply them out. 2x times 2x is 4x squared. 2x times 3 is 6x. X times x, x squared. X times 1 is 1x. X times 2 is 2x. And 2 times 1 is 2. So what do I get here? I get 4x squared plus 6x plus x squared. 1x plus 2x, because remember I can add diagonals, is 3x plus 2. Now notice that I can add 4x squared plus x squared. So that equals 4x squared plus 1x squared is 5x squared. Then I have 4x squared goes with the 1x squared. Then I have a 3x, so the 3x is next. And then I have a 6 times a 2, and that is, or 6 plus a 2, sorry, is an 8. So there's my answer. All right? All right, next question. Find the area of the shaded region. What's interesting about this problem, if the length is 2x plus 1 and the width is 3x plus 2, to find the area, I'm basically doing a Punnett square. So stay with me here for a minute. What I want to do is, it's two pieces here, so I'm going to break this up into two pieces. And it's two pieces here, so I'm going to break it up into two pieces. And right here will be 2x plus 1. And right here will be 3x plus 2. So it's actually the exact same problem again. To find area, you do length times width. So to find area, you're doing 2x plus 1 times 3x plus 2. Well, that's exactly what we've been doing. When you do Punnett squares, you're actually finding the areas. Right? You're doing lengths times widths. So let's do that. 3x times 2x is 6x squared. 3x times 1 is 3x. 2x times 2 is 4x. 2 times 1 is 2. At the diagonal, I get 6x squared plus 7x plus 2. And my friends, that is easy. Next example. All right, in this problem, I'm going to try to find the area. All right, so let's walk ourselves through this for a minute. To find the area of this triangle, if you find the area of the rectangle and then you cut it in half, what did you not find the area of the triangle? Because if you look at this, if you cut this in half, this is half of that rectangle and this is half of that rectangle, so the shaded region is half of the whole thing. So what I'm going to do is this. I'm going to do x plus 1 times x plus 2. That will give me the area of the whole thing. But then I need to divide it by 2 at the end. All right? So that's what I'm going to do. I'm going to multiply x plus 1 times x plus 2. What do I get? Well, x plus 1, x plus 2. X times x is x squared. X times 1 is 1x. X times 2 is 2x. And 2 times 1 is 2. Right? So I get x squared plus, at the diagonal, 3x plus 2 divided by 2. Now there's a 1 there, so distribute that 2 to everything. And my final answer is 1 half x squared plus 3 halves x plus 1. Because 2 divided by 2 is 1. That's my answer. Any questions? If you have any questions there, you can ask me about that one. That one's a little bit harder, so if you need to come to class and ask more questions, I totally understand it on that problem. On the final question is very, looks difficult, but it actually isn't. I call this the frame question because the shaded region is like the frame of a picture, and you're trying to find out what's the area of the frame. Okay? Well, let's figure out how long is this side. Well, the best way to figure that out is to do this. Break it up like that. How long from there to there? From there to there is 12. How long from there to there? Well, from there to there is x, and from there to there is x. And if you do it the same way on the width, from there to there is x, right? From there to there is 12, and from there to there is x. So how long is the length? Well, it's x plus 12 plus x. So x plus 12 plus x is actually 2x plus 12, right? Okay, so this side is 2x plus 12, and this side is the exact same thing. It's 2x plus 12. So I'm really going to multiply 2x plus 12 times 2x plus 12, right? Now, if I multiply, this is what you have to understand. If I multiply 2x plus 12 times 2x plus 12, what I end up finding is the area of the entire rectangle. But I don't want the entire rectangle. I actually just want the gray region. So if I multiply this times this, I find the area of the entire thing. So what part did I not want to include? Well, the white section, right? So in actuality, the equation that I'm going to use to solve this is 2x plus 12 times 2x plus 12 minus what? Well, minus the white region, which is 12 by 12, which is 144. Does that make sense? Find the area of the whole thing and subtract the middle. All right, so I need to multiply this out, don't I? Which means I have to make a Punnett square. So let's do that. It's 2x plus 12 by 2x plus 12. 2x times 2x is 4x squared. 2x times 12 is 24x. 2x plus times 12 is 24x. And 12 times 12 is another 144. So what do I get? Well, I get 4x squared plus 48x plus 144. Now here's the cool part. This is this. So 2x plus 12 times 2x plus 12 is this. Then I'm going to subtract 144. So what's going to happen? Well, these are going to knock each other off, and I'm left with 4x squared plus 48x. That tells me that the area of the frame is 4x squared plus 48x. So if I knew what x was, I could find the area. All right? Well, there you have it, Punnett squares, how to multiply polynomials. It is by far one of my favorite lessons of the year because I really do think it takes a hard concept and makes it easy. Plus, you've probably been doing these in science class before. That's in fact where we get the word Punnett squares from, is in a science class. But they're very useful and they make a hard concept a lot easier. So I hope you use them, and good luck.